Welcome back to the lecture number 4 on Fourier integral. Here we will see one interesting problem, how to represent that function into Fourier integral form. So the problem is, find the Fourier integral representation of the function f of x, and which is defined like this. So the first step of the problem, means first step of the solution, how to solve, is to check the function is even or odd. So how to check? So take x equal to minus x, then f of minus x will be what? It will be minus e to the power minus ax when minus x less than 0. Then e to the power minus of minus x, that is e to the power ax when minus x greater than 0. Okay. So this again we can write it as minus e to the power minus ax when minus x less than 0 means what? X greater than 0. E to the power ax when minus x greater than 0, that means x less than 0. So this, now if we compare this with the given function, then we can see that when x greater than 0, here we have minus e to the power minus x, but in the problem x greater than 0 we have e to the power minus ax. Okay. Now when x less than 0, the value is e to the power x, ax, whereas in the problem it is x less than 0, the function value is minus e to the power ax. Okay, that means this is nothing but minus f of x. So when f of minus x is minus f of x, then we say that the function is odd. So when the function is odd, then what is the Fourier integral representation of the function? So that time the function will be 2 by pi, okay, from 0 to infinity sine w x 0 to infinity, here what? F of v sine wv dv dw. So we have directly applied the formula. You can see how this formula came in lecture 1, lecture 2. You see those videos, you will get idea how we will get this integral representation. Now we will solve this one. So we will write 2 by pi 0 to infinity sine wx, then 0 to infinity. Now f of v, okay. So when x is greater than 0, because we are seeing 0 to infinity, so when x is greater than 0, we have function e to the power minus ax. So we'll have e to the power minus av sine wv dv dw. Clear? Now we will solve this. Okay, first we will solve this, then we will see the total integral. Okay, now here we have to see, or here we will apply this formula. If we have the integration like e to the power my ax, okay, e to the power ax sine bx, okay. So what is the formula for e to the power ax sine bx? It will be e to the power ax divided by a square plus b square whole into a sine bx minus b cos bx. So how we are getting this thing? If we take e to the power ax one function and sin bx another function, and we use integration by part formula, then we can get this formula. Similarly, if we have cos, then what will happen? E to the power ax cos bx dx, then same factor will come, e to the power ax divided by a square plus b square whole into. Now here it will change. What? A cos bx plus b sin bx. Okay. So here we will apply the first formula because we have e to the power ax sin bx form. So if we apply, then what will happen? Let's see. So first 2 by pi will remain same, then 0 to infinity sin wx. Then inside this we have to apply the formula. What is that? E to the power minus ab is there. So e to the power minus ab divided by a square plus what? Here bx is there, but here what? W b is there. So a square w square whole into what? A sin bx. So in place of a, what is there? Here we have minus a. So minus a sin bx, in place of b we have w. So wv minus w cos wv. Okay, so this thing, and the limit will be from 0 to infinity, then write dw. Finish. Now we will solve this bracketed value first. So how to do? 2 by pi 0 to infinity sin wx within bracket. What will happen? Now if we put infinity here in place of b, what will happen? This e to the power minus ab will be 0. So if 0 will multiply with this factor, total will be 0. So I will write 0, then minus. If I put 0 in place of v, so what will happen? It will be 1. So 1 by a square plus w square. We will write that one. Now inside bracket what will happen? If I put 0, sin 0 is 0, but cos 0 is 1. So minus w into 1. So that is minus w will get. Then dw. So finally we will get 2 by pi times 0 to infinity what? Sin wx whole into what? W by a square plus w square dw. Yes? Yes or no? So this again we will write. So f of x we are getting 2 by pi 0 to infinity w sin wx by a square plus w square dw. Now finally if we take 2 by pi to left side, it will be pi by 2. So we will get 0 to infinity w sin wx by a square plus w square dw equal to pi by 2 times f of x. But what is pi by 2 times of f of x? It will be minus pi by 2 e to the power ax when x less than 0, and pi by 2 e to the power minus ax when x greater than 0. So this is our answer. So in this way we can apply Fourier sine integral and represent the function. So you collect or gather some problems on Fourier sine integral, solve it. If you find any difficulty, any idea, any tricks, then you share in the comment box. I'll read and try to reply all the comments. Thank you.